Hello students. Student, in the last lecture just we have to discuss the questions of exercise 1.3 and the sum of questions student related to the basic theory of the inverse as well as the some composition type of questions we have to just solve in the last video. So some of the remaining questions are to be also there. So today student we will complete this exercise and some remaining questions just we have to solve here. So you can see each and every question carefully and just you have to notice what type of mistakes generally we have to make and you how to write the any questions in the your examination copy. Each and everything we have to just see in this particular video. Is it to be clear? So we will start the some remaining question of this exercise 1.3. So we will take the question first of all. So you can see the exercise 1.3 student, just we have to solve up to the question number. I think this question number 6 is to be solved. Now today we will start with the question number 7. So you can say that the question number 7 says that consider f is to be defined from real number to real number and given by f of x equals to 4x plus 3. Then we have to show that f is invertible and find the inverse of f. Student, all the questions are of the same type of format. Some type of different functions are to be sometime will be changed. Otherwise the all questions will be same and we will do the solution of each and every question in a very similar or in a very systematic way. So next we will take the question number 7 and we will see the answer of this part. Then this function is to be given from r to r. So the question number 7 we are writing here, the function is to be given from r to r and this particular function is to be given as 4x plus 3. Now first of all we have to show that the given function is said to be the bisective or not, because the bisective function will be the invertible, means whose inverse will be existed, otherwise the inverse will not be existed here. Or otherwise student was another way to check the invertible function, means we can say that this particular function fx is to be taken as y and we will convert this x in terms of y, then we will get the another function g of y, and then after we have to just calculate the two things. We have to just calculate the fog y and gof x. If both are said to be the identity function, then you can say that g is said to be the inverse of f and you can say that f is the invertible function. So there are two ways by which you can just calculate the inverse and you can just check whether the given function is said to be the invertible or not. So basically student, the first of all just we have to check the one means we know that if fx is bisective, we know that if fx is bisective, then it is said to be invertible function. It is said to be invertible function. Is it to be clear? So for the bisective case, we will just check whether the given function is 1 1 or not, on 2 or not. Is it to be clear? So the very basic condition for 1 1 you know very well because various type of questions we have to discuss. So let f x1 comma x2 belongs to the set of real number such that f of x1 equals to f of x2. Now student, you can say that this is 4x1 plus 3 and this will be equals to 4x2 plus 3. Now a very simple calculation, this 3 will get cancelled out. After that 4x1 equals to x2, then you will get the x1 equals to x2 always. And student, I think each and every student know very well about this situation, because if we are taking x1 equals to x2 and always we will get this result, then it is said to be 1 1 function. So you can say that it is 1 1 function. Now the second thing student, just we have to check for the onto case. Just we will check for the onto case. So in the case of onto, basically first of all we will take let of f of x will be equals to y and you can say that this is 4x plus 3 equals to y and we can say the value of x will be y minus 3 divided by 4. Now student, for the onto function, what should be the basic and necessary condition, you know very well, because if we will take the set of codomain, means the set of values we will take from the codomain, and codomain is again is to be given as set of real numbers, means you can say that for all y belongs to r, whether we will check the x belongs to r or not, means the domain will lie in the set of real number or not, or you can say that this particular y has its pre-image or not. We have to check this thing. Is it to be clear? So basically you can just put any of the real number here, student. After the calculation, basically this y minus 3 upon 4 definitely will belongs to the real number. So for all y belongs to R, you can say that x will be also belongs to R. And in this case, in this situation, we can say that so it is onto. So it is onto function. So, and student, if any of the function is said to be the 1 as well as onto both, then it is said to be the bijective function. It is said to be the bijective function. And in the case of bijective function, you know very well the inverse of any function will be existed, and you can say that the given function is said to be the invertible. So just we have to prove that the given function is bijective, because you can check this function is 1 as well this function is onto. Is it to be clear? Now how the inverse will be defined here? So the inverse of f we have to write inverse of f. You can you can write here inverse of f. Just we will write, then inverse of f is f inverse equals to, how the inverse will be there? So student, this particular part is said to be the inverse. Here we can say that this is written as x minus 3 divided by 4. Again I am saying, student, the name of variable you can use according to you, and generally if the any of the functions should be given in terms of x, then its inverse will be also defined in the terms of x. But just we have to mention the domain and codomain, because here in the case of inverse, just we can say that this codomain will become the domain and domain part will become the codomain. So you can just specify here this part also. F inverse is also to be defined from R to R, means after just interchanging codomain and domain, in this particular case there should be no problem is to be there, because here you can say that again the set of real number to real number, the function is to be given. So in this particular type of method, student, because you can use the other option also, because in that option just we have to convert the function like this, then it will be taken as the g of y. After that we have to find the fog x and g of y, and in each and every case if we will get the identity function, then the given function is said to be the invertible function, and you can say that g is also said to be the inverse of f. So student, either of the method you can check, either the bijective format you can just use to calculate the inverse or to check the invertible function, or you can just use the composition method also. Both the methods are to be the very important for us. So student, we will move to the next question, but before that pause the video to note it down, then we will take the next question number 8. Is it to be clear? Next question number 8, you can just read the question number 8 first of all from here. So consider the function f r positive to 4 to infinite given by fx equals to x square plus 4, so that f is invertible with the inverse f inverse of the given by this f inverse of y will be equals to square root of y minus 4, where r plus. So basically what should be r plus? It is to be given r plus is the set of all non-negative real numbers. Generally student, there should be a problem related to the 0, because 0 is never said to be the negative, never said to be the positive. But in this case, this r plus is the set of all non-negative quantity, means here the 0 will be also included. First of all we have to keep in mind this thing. Is it clear? Otherwise you will face some problems related to the 0, because here r plus is the set of all non-negative real numbers, means 0 and all positive real numbers are to be included here. Is it to be clear? So we will see the solution of this particular question. So the question number 8, is to be given as any function f is to be given from r positive to 4 to infinite. Is it to be clear? And the function fx is to be given as x square plus 4, where r positive, where student the r positive, you can say that this r positive means you can just write like this, 0 to infinite. Is it to be clear? So this is the meaning of r positive, because set of all non-negative real numbers, so 0 is also to be included here. That's why we have to use the close bracket. Is it to be clear? So you can just understand the meaning of r positive here. Then after again the very similar question that we have to discuss in the question number 7, because in this question again student we have to just prove that whether the given function is said to be invertible or not. So again we know very well, student, if any of the function is said to be bijective, and then its inverse will be possible, and the function is said to be invertible. So for the bijective function, so again we will write if fx is bisective, fx is bisective, then it is said to be invertible. It is said to be invertible. Is it to be clear? And student, for the bijective function, I think you know very well, the function should be 1 1 as well as onto both. So first of all we will check the 1 1 and onto conditions for the given function. So first of all we will check the 1 1. So for 1 1, let x1 comma x2 belongs to R positive. Is it to be clear? Means you can take any of the real number from the R positive from 0 to infinite, such that f of x1 equals to f of x2. Now student, you can say that x1 square plus 4 equals to x2 square plus 4. Now easily you can say that x1 plus 4 will be get cancelled out, and now x1 square equals to x2 square. Now we will check what are the x1 and x2. So the x1 x2 only belongs to the set of positive real numbers or non-negative real numbers, you can say that. Means student, if you will just simplify the condition, then only we have to write the x1 equals to x2, not plus minus, because here x1 and x2 both are belongs to the set of positive real numbers. No any kind of all real numbers we are included. Suppose it is to be given R, then you can say that minus 2 square will be 4 and plus 2 square will be 4. But here you cannot take any of the negative value as the value of x1 and x2. That's why always we have to just obtain the answer as x1 equals to x2, and in this case, so it is the 1 1 function. Is it to be clear? Next student, we will check for the onto. So for the onto, we can say that let f of x will be taken as y, and in this case you can write x square plus 4 equals to y, and x will become square root of y minus 4, because here we are again not saying the plus or minus sign, because student, you know very well about the x belongs to the R positive, and R positive means only the positive real numbers are to be included here. Now student, for the onto we will check the pre-image of codomain, and here the codomain will be given from 4 to infinite. So for all y belongs to 4 to infinite, suppose you can take value of y as 4, then y will be 4, then 4 minus 4 will be 0, square root of 0 will be 0, then you will get the value of x 0, and this particular 0 will lie in this domain or not. Means this particular element 4 value of y equal to 4 has the pre-image. Suppose we have to take the value 5 here, then 5 minus 4 will be 1 and square root of 1 will be 1, and this 1 definitely will belongs to the set of real numbers. Means this particular answer is always found to be positive in this particular given codomain. Means you can say that for all y belongs to R, x definitely belongs to the R positive, so it is onto. Is it to be clear? Now if the function is said to be 1 1 as well as onto both, then you can say that the function is always said to be the bijective function. So it is said to be the bijective function, and in the case of bijective function, the function is always said to be the invertible, and inverse you can write here. So what should be the inverse of f? So inverse of f is f inverse equals to. So how the inverse we will write here? So either you can use this particular thing as an inverse, because in the case of inverse just we have to revert the thing. Means here the in the question y should be written in the form of x, but here we will change x will be written in the form of y. But before that the function should be bijective, otherwise the inverse will not be possible. So f inverse you can write here square root of y minus 4, or you can also write as x minus 4, no problem. But here we have to mention the codomain and domain. Is it to be clear? So student, here in the case of inverse, this codomain will become the domain and domain will become the codomain. So the f inverse will be defined from 4 to infinite to R positive. So this will be the codomain and domain. This will be the very important. Then after writing this part, you can use name of variable as y or x. There should be no problem, because you can take any value of y here. Suppose you can write x, then there should be no problem. The value will be taken from here. So always we have to mention the domain and codomain part. Is it to be clear? So student, I think the things are to be very clear to you, because here the second method we are using here, to calculate the inverse of any functions. And the another method we have to already use in the previous questions, where fog x and gof y both are said to be identity function, then g is said to be the inverse of f. This thing is to be used in the previous question. So this thing is to be again very important. You can use this particular method also when we have to calculate the inverse, or we have to just prove that whether the given function is said to be invertible or not. Is that to be clear? So student, pause the video to note it down. Then we will take the next question, that is question number 9. So next question number 9 we are taking here. So in question number 9, you can just again see the very similar type of questions. Consider f r positive to minus 5 to infinite given by fx equals to 9x square plus 6x minus 5, so that f is invertible with f inverse y equals to this. Again, the very simple question is to be there, no problem. Any quadratic equation is to be there. Student, in the theory part we have to just discuss such type of questions. Is it to be clear? Now I will just tell this question with the another method of bijective case. Is it to be clear? Because in the theory part such type of questions we have to solve with the help of composition. Means first of all we have to calculate the g of y. After that we have to calculate the fog and go of both, and both are said to be identity, then g is said to be the inverse. Is it to be clear? But now we are using the another approach to just prove that the f is invertible or not. So again we will see the question r positive to minus 5 to infinite, and here this fx is to be given as 9x square plus 6x minus 5. So we will take this question. Question number 9. Question number 9 says that any function f is to be defined from r positive to minus 5 to infinite, and fx is to be given as 9x square plus 6x minus 5. Is that to be clear? Again we will check the question whether it is to be correct or not. So basically here 9x square plus 6x minus 5. 9x square plus, you can say that the question is 9x square plus 6x minus 5, no problem. Now we have to just check whether the given function is said to be invertible or not, and if it is invertible, then we have to find the inverse also, no problem. Again the same similar kind of method we are using. Suppose the given function is said to be bijective, and in the case of bijective function definitely the function is said to be invertible, and inverse easily you can just define where also, because to calculate the inverse just we have to revert the things. Suppose this is taken as y, then y should be written in the terms of x. So in the case of inverse, just we have to calculate the x value of x in terms of y, and that should be the inverse or not. It will be dependent that whether the given function is said to be bijective or not. So before declaring the given revert function will be declared as the inverse or not, we have to check whether the given function is onto or not. So basically student, again we have to say that first of all we will check the 1-1 condition, means whether the given function is 1-1 or not. So let x1 comma x2 belongs to r positive. Here r positive, again the same kind of r positive, means here set of all non-negative real numbers, means you can just say that the 0 is also to be included here. Generally the 0 is not to be included here, but here r positive is the set of all non-negative real numbers, that's why we are including the particular 0 here. So x1 comma x2 belongs to r positive such that f of x1 equals to f of x2. So basically student, in this case you can write here 9x1 square plus 6x1 minus 5 equals to 9x2 square plus 6x2 minus 5. Now in this case I think there should be no problem. Next student, you can just see that this minus 5 will get cancelled out. Now you can just separate the x1 and x2 here. So this 9x2 square is to be shifted in the left hand side, then 9 will be common. Here you can write x1 square minus x2 square, and this 6x1 will be shifted in the right hand side, then it should be written as x2 minus x1. Now you can just factorize this part, x1 square minus x2 square as a square minus b square. So I think you know very well a square minus b square is a plus b or a minus b. So this thing you can write here x1 minus x2 and x1 plus x2. Next this part is to be shifted here, then you can write here this will be changed x1 minus x2 and this will become 0. Some of the students say, sir, why this is not said to be negative in this part? Student, just I am just reverting the sign of this part, that's why this part is to be taken as positive here. So there should be no confusion related to this part. Is it to be clear? You can see the calculation carefully. This is x2 minus x1, in this side this is x1 minus x2. Next you can see x1 minus x2 will be common. So x1 minus x2 will be common, then the remaining part is 9. This is 9x1 plus 9x2, and here you can say that this is 6 and this will be 0. Now student, this particular thing and this particular thing will and product of both the things will be set to be 0 here. So what condition will be obtained here? Either we will get x1 x2 or not, we have to check this. So student, you can check this expression. This expression never be negative, because here x1 and x2 is what? x1 and x2 belongs to the R positive. So if any of the positive number you are just putting here, then this will be implies a numerical value. This particular part not set to be 0. Means for x1 comma x2 belongs to R, you can say that for x1 comma x2 belongs to R positive, this particular thing 9x1 plus 9x2 plus 6 is always said to be positive. Means this should be not negative. So you can just say that this thing is not negative, this thing is not said to be 0. Means this expression will be 0 due to this part only, not of this part, because this part will not be 0 anywhere. So basically always you can say that x1 minus x2 equals to 0, and you can say that x1 will be equals to x2. So before that declaring x1 equals to x2, just we have to calculate this thing, whether the answer of this part will be 0 or not. So student, for x1 x2 belongs to the set of real number, then this particular real positive real number if you have to provide here, then this expression will never be 0. So you can say that x1 will be always said to be equals to x2, and so it is 1 1. So it is said to be 1 1. So basically you can easily prove that the given function is said to be 1 1. Now the second thing is we have to just prove that whether the given function is onto or not. So in this particular case of onto, student, we have to do some type of calculations, because here the quadratic equation is to be given, then definitely in a very easy way this x will not be get separated in terms of y. So we have to use the some basic completing the square method. So in this case, let f of x will be taken as y, then 9x square plus 6x minus 5 equals to y, and you can just use the completing square method. And I think student, you know very well about the completing the square method, because in the previous classes 9th or 10th you have to just use the method where just we have to take the common as 9. First of all we have to make the coefficient of x square as 1. So x square, this will be 6 by 9. 6 by 9 will be written as the 2 by 3x, and this will be 5 by 9, and this will be equals to y. So basically we have to take the 9 as common to make this coefficient as 1. Now student, another step we are doing, we have to write the two terms. Now we have to find the half of this coefficient, half of coefficient of x we have to obtain here. So this coefficient of x will be 2 by 3, and half of 2 by 3 means you can get the 1 by 3. So 1 by 3 square is to be get added and subtracted. This thing is the very important. Means what we are doing here, we will calculate the half of coefficient of x. So coefficient of x will be 2 by 3. So 2 by 3 is to be multiplied with 1 by 2, then you will get the 1 by 3. So basically student, the number you will obtain, then its square is added as well as its square will be subtracted. Is it to be clear? So that these three parts, a square plus b square plus 2ab will become, so 9 times of this part will be written as x plus 1 by 3 whole square. Now the remaining parts you can simplify here. So this is minus 1 by 9 and this is minus 5 by 9. So it will be minus 6 by 9. So you will write here minus 6 by 9, and this will be equals to y. After the 9 is to be get multiplied here, then x plus 1 by 3 whole square minus 6. You can say that this is 9 will be get cancelled out here. So this is minus 6 equals to y, and 9 into x plus 3 whole square will become y plus 6, and this 9 will be get shifted. So x plus 1 by 3 you can write here y plus 6 under the square root divided by 3, because here again student, x belongs to the R positive, then we are not taking plus or minus. Suppose x belongs to only the real number, then definitely when we have to take this particular square root, then we have to write the plus or minus, and here the square root of 9 we will write here 3. Is it to be clear? So basically here this expression you will get. Now you can say that this x will written like this, this plus by 1 by 3 will be shifted here, then minus, so it will be root of y plus 6 minus 1 divided by 3. So first of all, how the calculation will be proceed to convert this given function as x in terms of y. So this thing is the very important. Student, you can just see the calculation again and you will do such type of calculations, because this is only the method of completing the square, nothing more, and much more complicated part is to be there. So you can do such type of calculation to revert the function. Now what the function said to be onto or not, what we will do, we will take the codomain, and codomain of this function is to be given from minus 5 to infinite. Suppose we are using y as minus 5. So if we will take y as minus 5, then minus 5 plus 6 will be 1, square root of 1 will be 1, 1 minus 1 will be 0, 0 divided by 3 will be 0. Then you will obtain the value of x as 0, and 0 belongs to this domain or not. So definitely student, here R positive means we are including the 0, then 0 will be always said to be found in R positive. So basically you can say that if we will take more values of y from the codomain, suppose minus 4 you can take, then it will be a positive number. Inside the square root it will be a positive number. So basically if any positive number is to be there, it is to be get subtracted from minus 1 and divided by 3, then you will always get the positive real number, no negative real number is to be obtained. So basically you can say that for all y belongs to minus 5 to infinite, definitely student, the x belongs to R positive, and you can check some of the values, because here this particular y plus 6, suppose minus 4, minus 3, minus 2 and any other values you can just use here, then definitely the numerator part is always found to be positive, and positive number is to be divided by 3, then any real number you will get, but that should be the positive. So this x belongs to the R positive always. Now student, if for all codomain, whole codomain, the pre-image of the image elements are to be existed in the domain, then it is said to be onto, means so it is onto. So it is onto. So basically student, any of the function is said to be onto and 1 1 both, then it is said to be bijective function, you know very well. And in the case of bijective, invertible function is to be there and inverse will be existed. And how the inverse will be defined, you can see the answer here. So you can see the inverse here. So inverse of f is f inverse. So you can write the f inverse here. So f inverse you can write here. Then f inverse will be defined as the value of x in terms of y, we will write here y plus 6 minus 1 divided by 3. But this is the not sufficient answer student. We have to just also mention the codomain and domain of both the functions. So basically the domain and codomain will be revert also, because the domain and codomain of the f function is R positive to minus 5 to infinite. Then we can say that this codomain will become the domain and domain will become the codomain. So the domain of this particular function is minus 5 to infinite to R positive. So this is the basic and complete answer of this particular given inverse of the functions. Is it to be clear? So student, in such type of questions where we have to prove the whether the given function is said to be invertible or not, we have to just say one thing, just we have to prove the function is bijective. And in the case of bijective, definitely we have to check the 1 1 and onto case, and if both are found to be true, then you can say that the inverse will be possible and function is said to be invertible. But in this case, any quadratic equation is to be given, then how the complete value of x should be written in terms of y, there should be some difficulties are to be found in this case. So student, we will use the completing the square method, where definitely you can say that if completing the square method is to be get used, then you will get the value of x in terms of y. Is it to be clear? So this is the answer of this question number 9 of your NCERT. So student, pause the video to note it down the answer. After that you can just simplify the question, so that the concept will be get clarified to each and every student, and the calculation part is to be very important in this case. Is it to be clear? So next question number 10 we will take here. Next question number 10 you can see here. So in this question number 10, f x to y be an invertible function, so that f has unique inverse. So student, basically in this particular kind of questions we have to use remember this result always, because this is the standard result, because in any of the cases if inverse will be existed, then it will be always unique. Is it to be clear? Now we will prove this thing also, but we have to keep in mind always this thing. Is it to be clear? So basically f x to y is to be given, and it is said to be the invertible function. Already in this question number 10, f any function is to be given from set x to set y, and it is said to be invertible function. It is said to be invertible function, and any of the function is said to be invertible, then student, automatically it is the case of bijective function. It is the case of bijective function, and in the case of bijective function, you know very well, the given function is always said to be 1 1 and on 2. So we have to just prove that inverse of this f will be unique. Prove that inverse of f will be unique. This thing we have to just prove in this question. So basically, first of all, suppose we are taking the two kinds of inverse. Suppose G1 and G2 are said to be the two inverse of this f, and suppose in this case we have to just prove that G1 equals to G2, then automatically, student, you can say that the inverse of that function will be unique. So let first of all we have to take the two different, or you can take three more different inverse, G1, G2, G3, and you can take many more inverse initially. Means just the revert things we are taking here, and after that we have to prove that the things are always said to be found equal. Then definitely the unique inverse theory will be possible. So let, to simplify this question, let G1 and G2 be the two inverse, of f. Is it to be clear? Which is to be defined from y to x. Is it to be clear? So now student, now G1 and G2 are said to be the two inverse of this particular function. Then you know very well about the concept of inverse. You are saying that if G1 and G2 are the two inverse, then fog y and gof y both are said to be the identity function. So then we know that f of z1 of x equals to identity function. You can say that identity function, and this will be also equals to f of z2x, because in the case of inverse, if there are two inverse we are declaring for the given function f, then this fog and gof both are found to be the equals to the identity function x or y, no problem. Is it to be clear? Now you can say that f of z1x equals to found to be f of z2x. Now this should be identity and this should be identity, then these are said to be the equal. Now how this thing is to be get written? So you can write f of g1x equals to, this will be written as f of z2x. Now student, very important thing, this particular function is said to be invertible, and in the case of 1 1, what we are doing, generally in the case of 1 1 we are taking x1 and x2. x1 and x2 belongs to the domain such that f of x1 equals to f of x2, then we will get the condition x1 equals to x2. So it f is invertible. It is to be given in the question. We are not saying invertible. This is to be given in the question. F is invertible. Then we can say that, then if f of x1 equals to f of x2 implies that x1 equals to x2 or not. This condition we have to use here. Suppose f is invertible function, then you can say that if f of x1 equals to f of x2, then it is said to be x1 equals to x2, because the condition of 1 1 will be get satisfied here. So basically student, if this whole part will be taken as x1 and this whole part will be taken as x2, then the situation will be like this: f of x1 equals to f of x2, and always you know very well the given function is always said to be invertible. So f is invertible, then you can say that g1 of x will be equals to g2 of x. Now student, you can say that both the functions are found to be same, but here what we are assuming that g1 and g2 are the two different inverse of the given function. So here so inverse will be unique. So you can say that inverse will be unique of any given function which is to be defined from x to y if the function is said to be invertible. So basically student, in such type of questions we have to take the reverse things, means just we are saying the more than one inverse will be there, but after the simplification you will get all the different functions g1 g2 are said to be found equal, because f is said to be invertible, means it is said to be 1 1. So use the condition of 1 1, then you will get the required result of g1 of x equals to g2x, means both the functions are same, then no different inverse will be there, and you can easily shows that the inverse of the given function said to be unique always. Is that to be clear? So a very systematic question is to be there, always the functions are not to be given, then again student you can use the systematic thing that we have to describe in the theory section, and you can just simplify the answers. Is that to be clear? So pause the video to note down the things. Student, next question we are taking the question number 11. So next question number 11 we can see here. In this question number 11, again consider the function f1 2 3 to abc such that f of 1 equals to a, f of 2 equals to b, f of 3 equals to c, then find f inverse and so that f inverse of inverse will be equals to f. Again the very similar and simple type of questions, you can just see the question number 11. So just we will see the solution of this question. And student, in this particular question number 11, any function f is to be defined from 1 2 3 to a b c. This function is to be defined like this, and it is to be given as f of 1 equals to a, f of 2 equals to b, and f of 3 equals to c. These things are to be given. Is it to be clear? Now student, you can make the mapping here. You can map the mapping. Suppose this set is to be taken as a and this set is to be taken as b, then function is to be defined from a to b like this, 1 2 and 3. This is said to be a, b and c. So this is the mapping given as per the question. So first of all student, on behalf of this mapping you can just check whether the given function is 1 1 or not. Definitely student, each and every element of the domain has the distinct image in the codomain, so it is 1 1. It is said to be 1 1. And along with, can you say about the what can you say about the onto? So basically in the case of onto, just we have to check the codomain whether the codomain has its pre-image or not. So basically all the codomain elements has corresponding some pre-image in the domain. So this function is always said to be the 1 1 plus onto. So it is said to be the bijective function. It is said to be the bijective function. And in the case of bijective function, you can say that the function can be invertible, and inverse of that function will be possible. So you can say that if any function f can be written like this, 1 comma a, this is 2 comma b and 3 comma c, then student easily you can just prove these things. The function is said to be 1 1 and onto on behalf of this mapping. Now you can just write the f inverse. F inverse will be written like this. Just we have to revert the ordered pair a1, this will become b2 and this will become c3, and this f inverse will be defined from now a b c to 1 2 3. Is it to be clear? So easily you can just obtain the value of f inverse. And again student, f inverse is to be made here. Suppose this f inverse mapping is to be drawn here, then you can draw the mapping for f inverse. So here now we will write ABC and here we will write 1 2 3. Again student, you can check the thing, because this particular function is again said to be the 1 1 and onto. This is said to be the 1 1 plus onto both, because here all the codomain element has the distinct image in the codomain, and each and every codomain element has the pre-image in the domain. Again this f inverse means its inverse will be also possible. Means again suppose we have to calculate the inverse of this f inverse. So you can just find the f inverse of inverse. Then we have to just revert the things, and this will be again written as 1 comma a, this is 2 comma b and this is 3 comma c, and you can check the function f which is found to be equals to f. So basically student, f inverse of inverse will be always found to be equals to the f, because in each and every case the function is said to be bijective. Bijective means 1 1 and onto both. So a very simple thing is to be asked in this question number 11. Just you can check the solution, and you have to just pause the video to note it down the each and everything. Next question number 12 we will take now. So next question number 12, you can see here. In this question number 12, student, f x to y be an invertible function, then so that inverse of f inverse is f, that is f inverse of inverse equals to f. The same question is to be there, means nothing will be changed in this question number 11 and 12. Only the thing that should be changed in the question number 11 and 12 as the basic function is not to be given. So no problem student, either you can take any of the example as previous example of the question number 11 you can take here, and you can just define the function f in general, no problem. Is it to be clear? So there should be no problem in the question number 12. Next question number 13 we will take now. So in this question number 13, f r to r given by fx equals to 3 minus x cube whole cube, then f of fx we have to just calculate. So now we will simplify the question number 13 here. f 3 minus x cube whole raised to power 1 by 3. So next question number 13 we will take here. In this question number 13, the function is to be defined from r to r, and this f of x will be given as x cube minus 3 whole raised to power 1 by 3. No problem. Student, just we have to calculate the f of fx. A very simple thing is to be asked here. So this will be written as f of fx. This will be written as f of fx. So first of all, we will use the fx here. Then fx is to be given as x cube minus 3 whole raised to power 1 by 3. Now this particular input will be taken as the input of this particular function f again. Is it to be clear? So the f function means, in the f function in place of x we will write the x cube minus 3 whole raised to power 1 by 3. So the answer will be written as x cube, here we will write the answer, then x cube minus 3 whole raised to power 1 by 3. Now this particular value of x is to be get substituted, and again we have to take the cube minus 3. So this particular answer you can just obtain in this case. Is it to be clear? So just we will write down the things here, and you can just write down the answer. So it is to be get solved, then student, the cubic part is to be get cancelled out with this 3, then it will become x cube minus 3, x cube minus 3, and here again you can say that the minus 3 is always to be given here. So in this particular kind of f of fx, what we are doing, basically the f of fx can be written like this, f of fx. Now fx is to be get substituted here, then it will be written as x cube minus 3 whole raised to power 1 by 3. Now again the things are that, student, just we are putting the value of x in this particular function. So the value of x will be taken like this. So this particular value of x, you can say that x cube minus 3. So the value of x will be x cube minus 3 whole raised to power 3, because here x cube will be there, minus 3 and whole raised to power 1 by 3 we have to write. So here we have to write the value of as whole raised to power 1 by 3. So easily you can just compute the things, and in a very systematic order you can just simplify the things. Is it to be clear? Because here f of fx just we have to calculate, then x cube minus 3 the given function is to be there, then fx is to be get written here. Now this whole value is to be again replaced with this x only, nothing will be get changed. So this x will be replaced by this value, and here cube will be there, and here you can say that this is minus 3 and whole raised to power 1 by 3 we have to write. So basically you can check the answer of f of fx here. I think there should be no problem to understand this particular question. Is it to be clear? So pause the video to note it down, the student. Next question number 14 we are taking. Question number 14 we are taking here. So question number 14 you can just check here. Just question number 14 says that let r f r minus 4 by 3 to r be a function as 4x upon 3x plus 4. The inverse of f is the map G range f to r, means already the codomain should be equals to the range, then definitely the function is said to be bisective, and just we have to calculate the inverse. Is it to be clear? So the given function fx will be equals to 4x upon 3x plus 4. 4x upon 3x plus 4. So next question number 14 we are taking. This particular function fx will be 4x upon 3x plus 4. Is it to be clear? And the definitely, student, the domain of this function will be given as r minus 4 by 3. R minus 4 by 3 to r. This particular thing is to be given here. No problem, student. First of all, let f of x will be equals to y. Let f of x will become equals to y. Then this is 4x upon 3x plus 4 equals to y. Then just we have to do the cross multiplication. Then 4x equals to 3xy plus 4y. Now you can just take the x as common. Then it will be 4 minus 3y that should be equals to 4y, and you will get the value of x as 4y upon 4 minus 3y. So this particular function g of y you can write here. So g of y will be equals to 4y divided by 4 minus 3y. Now student, if we have to convert the function, then this particular function g is said to be the inverse. But when it is said to be the inverse, when you can say that fog y equals to identity function of y, and gof x, and gof x will be equals to the identity function of x. In this situation, this particular function is said to be the inverse. So easily you can do the calculation for this part, but here the objective question is to be there, then there should be no problem, because the function is already said to be the invertible. So when we have to check the invertible case, then we have to check this condition. Otherwise, already the function is said to be invertible, then there should be no requirement to check this process. So basically student, here f inverse you can write as 4x upon 4 minus 3x, but we have to mention this thing. F inverse will be defined from this particular domain, codomain will become the domain, and this particular domain will become the codomain. So r minus of minus 4 by 3. So this particular answer is to be get checked in the options, and you will get the answer. Here student, there should be no problem to write the name of variable as x or y. You can use y or x, no problem, but we have to define this thing properly. Otherwise there should be some problem is to be there. So you can use the name of variable as x or y, there should be no problem. Is it to be clear? So you can check the option, and student, definitely in this particular exercise, each and every question will be get related with the inverse theory of the functions. And mainly in the examination student, you have to just see the basic thing. The questions are to be coming from the basic part of the inverse of the functions, where all the things, one, many one, bisective, composition, each and everything will be get checked related to the function. So this particular exercise is to be very important for the point of view of examination, and definitely the question will be asked from this exercise definitely. Is it to be clear? Means in examination or CBSE or RBSE or any state board examination which follow the curriculum of NCERT, so definitely that exam will contain the question of this inverse theory always. Is it to be clear? So we have to keep in mind the things, and student, the exercise is now to get to be finished. Now one more topic in NCERT is to be also included, but student, this topic is permanently removed from your NCERT. That should be known as the binary operations. Is it to be clear? So I will tell the some basic part of the binary operations, then we will move to the miscellaneous exercise. That should be the very important exercise for the point of view of practice, because where all the type of questions like relation, function, and each and every kind of cases we have to see in that type of questions. So we will solve the next part in the next video, that should be related to the miscellaneous exercise, and the some basic part of the binary operation I will just tell you. So you have to keep in mind whenever in any of the other examination, in spite of the board examination, if any of the questions will be there from the binary part, then you can just simplify the questions, and what are the basic definition, what are the basic things are to be there, we can understand the things in the next video. Till now student, you have to do the practice of this exercise 1.3 mainly. Is it to be clear? So we will meet with the miscellaneous exercise as well as the binary operation in the next video. Till that student, again you will simplify each and every question related to the exercise 1.3. Thank you.